I'm Mandemaker. I'm a researcher at Utrecht University in the Netherlands, and I'm working on the micro nanoplastic research field, working both on particle generation, but also on the characterization of micro nanoplastics and seeing what their potential risks are that come from those. So this research work is focused actually on the literature assessment, because the field of nanoplastic research is really expanding the last few years. It's sometimes easy to get lost. We wanted to synthesize our own nanoplastics for the research within the AURORA consortium. And to do so, we narrowed down all the options that actually existed in literature. And from this, we learned a lot for actual practical work that we will do for synthesizing the particles. Almost 90% of all the studies was focused on polystyrene. And this is because polystyrene is widely available commercially, whereas the other polymers are not, because they're also more difficult to synthesize. And this is a huge gap, because if you look at the plastics that are used worldwide on a daily basis, but also, for example, that we find in the waste streams, of course, for example, the polyolefins, polyethylene and polypropylene are dominating this. So polystyrene is not really in there. Not as much as that we find them in literature. And this gap, of course, is quite misleading, because now we are mostly studying health effects of polystyrene particles. But the particles that we might find in the environment are, first of all, not the shape, and second of all, not the polymer type of the ones that we are studying now. And this was confirmed in this literature study. Then we also dug into potential options to synthesize the other polymers, to give an alternative to the reader. We also presented a roadmap in which the reader can actually sort of follow a flow scheme of what might be nice for their own research. So within AURORA, we are of course focusing on early life stages. What we want to do, for example, is we want to establish protocols that we can use to, for example, digest the placenta tissue, to actually see if we can find these environmental particles in there. The fact that we now present these methods to generate your own, let's say, synthetic model nanoparticles, which we also use now within the AURORA consortium, provides us with a pathway to, let's say, increase the efficiency of our testing procedures. And then when we really want to study, let's say, the real deal, the actual samples, it will be way more efficient because we've already optimized our methods. We are now actually actively producing these particles on quite a large scale for research purposes. So within the AURORA consortium, all the work packages that do research are actually using these particles. We now have this background that supports the particles that we're going to use through the whole consortia. So it's not just a random guess. We actually went through literature and chose the best option for within the AURORA consortium. The field of micro nanoplastic research is very interdisciplinary. We really have toxicologists, we have material chemists, we have analytical chemists. It's so much fun to actually see that you're also crossing the borders to these other fields, and they're essential. And actually, I feel really excited being part of that, because it feels like you're working towards a larger goal. I think it's very important to mention, of course, that although we are talking now, this research was not only done by me, but big part of the work was also done by Karen van der Akker, who started in our group as a bachelor student. She did this as her literature thesis. Definitely credits to her and credits to everyone in this group for working on that. Where we started, of course, as a fresh field with some emerging papers and now a lot of literature assessment. I think in the coming years it will be really exciting, because the results from the big European consortia, for example, will come out. And then I think that in a few years from now, we might have more answers and a different vision on how we see these things compared to now. So I think that's exciting and something to look forward to.